Everywhere I look, there's all sorts of stuff laying around. Welcome back to another see-through rotary engine episode, but this time I have something very different for you. We're putting together a see-through liquid piston rotary engine.
That's beautiful.
This is an engine that was recently developed, and I like to think of it as a more advanced, improved version of the Mazda rotary engine, simply because apparently they fixed most of the issues that the Mazda engine had. If you've ever had a Mazda and broken an apex seal, they will destroy your life. You'll see what I mean in a couple minutes, but before anything, I have to get to work and build the transparent front housing for the liquid piston rotary engine and then hit up the East Coast. Oh yeah. We finally arrived at Liquid Piston here in Connecticut. This is going to be exciting. First time I'm going to see this engine in person.
Good morning.
What's up, Nick?
How are you, Nick?
You ready to rock and roll? Hopefully we can make this work.
Yeah,
Those are the last two covers we have.
Great. I'll carefully get on with it and start the assembly.
So would you call this like a version 2 of the Mazda rotary engine?
The major difference, which very few people think about, is the cycle. It's operated on the different cycle. We call it high efficiency hybrid cycle. And the reason for this name is that we cherry picked the best feature from Otto cycle, diesel cycle, and Atkinson cycle. And we combined them into a single geometry, which is depicted here. So we borrow the compression stroke from diesel because we're compressing to very high compression ratio. Then you add heat at the constant volume, which is extremely important. We expanding like all engines do, but we overexpand like Atkinson cycle. So we cherry picked this best feature from each cycle. That's why we call it hybrid cycle.
One of the biggest advantages of the liquid piston engine is its size and power to weight ratio. This engine makes about 4 horsepower and weighs a mere 4.5 pounds. I can hold it in one hand.
So we've got these 3 working chambers, and if we just look at one of the chambers at a time, what happens is we've got air and fuel that come in through the shaft. So that's actually our intake, comes in through the shaft. See here that intake port? So that's where the air and fuel mixture come into the engine. As the rotor is spinning, it's drawing in a vacuum. You see how this volume here is growing? And that's pulling in a vacuum, so it's pulling in the air and fuel mixture. And eventually the intake port moves over to the next chamber, and now this is a trapped volume. So this volume undergoes compression. This is where the gas is compressed. All of the air and fuel end up compressed into this combustion chamber. On the spark-ignited version of the engine, we spark it at this time. On the diesel version of the engine, we can inject fuel right now, and it'll burn as a diesel engine would. And then as the fuel burns, it pushes on the rotor, and that's actually your power stroke. That's where all the power comes from. And eventually the exhaust port opens up. So here you can see the exhaust port. It's just kind of the opposite of the intake stroke. And what it does is it pushes all the gas out of the chamber, and all the exhaust ends up inside of the rotor. So that's a whole cycle. For every revolution of the rotor, we get 3 combustion events happening in each of these chambers.
Simultaneously.
Yep.
So the exhaust stroke basically exhausts right through that little hole into the center section of the rotor, and then it mixes with the cooling air on its way out of the housing.
That's right. And so what comes out of the engine is actually like 10 parts cooling air and 1 part exhaust. So this is the intake that comes in through the center of the engine. Fuel gets injected out here, and then this is the exhaust that gets blown out the back.
The air actually travels through the middle of the crankshaft, through the rotor housing channel into the combustion chamber, and then the exhaust stroke travels right through that port in the rotor, into the rotor center section, and out these exhaust ports.
That's correct.
Now that we have a better idea for how the combustion cycle works with this engine, let's go back to the lab and see if the guys have the transparent cover set up on the test engine, get it mounted on the stand, get the high-speed camera set up so we can see inside of the engine while it's running in slow motion. We're technically in the lab. The guys put together most of the engine here, and the transparent cover that I made is all set, ready to go. This looks amazing. It is so hard to convey how amazing this thing looks in person. I just wanted to show you how it moves.
Beautiful. Just beautiful. Smooth and it's not scratching. You're absolutely right.
Let's get this mounted to the test bench, start it up, see what this combustion process looks like in slow motion. All right, Dave has the engine all set up, ready to go. The first thing that we're gonna run is gonna be propane. If that goes well, I'm gonna propose a crazy idea that I'm not sure that they're gonna be okay with. But we'll see. I got the high-speed camera all set up. Let's get this thing started and see something the world has never seen before inside of a liquid piston rotary engine while it's running in slow motion. All right, let's go. Just by seeing that rotor spin, it is so smooth. It's like magic. So satisfying. Ready to rock and roll. Let's see what happens. So that was the first run on propane, but since the lights were on, we really couldn't see anything. For this next run, I'm gonna cut the lights and then do one more run on propane with the lights off. That run went pretty well, but you really couldn't see the combustion very well. That's my same experience with the single cylinder Briggs when I ran the propane. Propane is lame. Unexpected and completely out of left field, the guys approached me and said that they're interested in running my crazy idea next.
Well, we can set up a way to meter in a small, precise amount of acetylene
directly into the intake of the engine.
What the heck?
Similar to what I did previously in my garage. Let's see how this comes out. I think it's gonna look awesome. Okay, so that looked pretty awesome. I could actually taste the acetylene in my mouth while watching that clip for some reason. For this next run, it's just the sweet smell of gasoline. We're gonna run it on gasoline, and that's something that everybody can relate to. We got the line hooked up right here, going directly into the intake manifold. The engine's all set up on the dyno, ready to go. High-speed cameras rolling. Let's see what this engine looks like running on gasoline in slow motion.
Here we go.
Okay, so that was the run on gasoline. That looked the most spectacular by a long shot. I mean, can't go wrong with good old gasoline. And it's been a long couple days. This day in particular has been extremely painful. All of our batteries are dead. We're all done. Everybody's exhausted. It's like past midnight here and we're just wrapping up this shoot. But all these guys are a good sport. They're all right here in the test cell. Everybody's still working here, working hard. And all these engineers stood behind with us to finish up this video, and this was quite an experience. So hopefully you enjoyed it. Don't forget to check out the Liquid Piston Engine. I'm gonna leave a link in the description below. This is obviously not a sponsored product or anything like that. This is just technology that is pure genius. The rotary, we all knew that the rotary had a lot of potential, but there was issues like the seals and stuff like that. And these guys seem to address all of those issues. And this, I think, is the way the rotary should have been. Definitely check that out. Tell me what you think in the comments below. Again, thanks for watching. See you in the next video. Here in their lunchroom, and this episode's just about done, but I want to make sure that all the engineers get credit. Most of the projects that I film, I build, I engineer them, design them, and put them together. But this particular project is all these guys right here. These are all the engineers. I think there's way too many projects and too many companies where the engineers just don't get any credit. And these are the guys here that actually make stuff happen. That's it. So I want to make sure all these guys get credit. So I want to thank everybody for all their hard work. And when you watch the Liquid Piston Engine running, all of these brains here and all of these ideas are coming together into one machine to make all that happen. So I think it's really important. And I just wanted to give everybody credit. Don't forget to subscribe, everybody.
If you can't seal the engine, then you really don't have an engine.